Up, up. Let's see. Let's do like this. Yusuf, can you see the whole screen? It's okay? Perfect. So we just need to start there. Today the goal is to actually just give you guys an introduction to breathwork, okay? It's gonna take, you know me, I could do this for a really long time. I studied a lot of this, so I tried to create a little bit of a lecture that is not too complicated, that gives you a really clear sense of just for today, the different, let's say, uh, understandings of how breathing works. Okay? We're not going to talk about the nervous system today, but we're going to do it next week. The nervous system is obviously what we're going to affect by breathing. Okay? So the first thing today is basically breathing, next time nervous system, and then the connection. And we're going to get all spiritual about the different nadis and the energy channels and this kind of stuff. But before I'm going to get into the breathing, I'm going to ask you what happens when we get scared. So I give you a question right now, Ali, right? You're going across the street. You're walking across the street and there's a car coming at you. What's your reaction? What happens to your breath?
It will be very fast, very quick.
You're going to go like,
Panicking.
you're going to get
Yeah,
shocked. One quick
yeah,
inhale, right?
yeah.
And if you do this right now, all of you, you're gonna feel right away that actually you're stimulating yourself, like you're getting anxious. Okay? And what's the opposite, right? Let's say you're taking a shit, Yusuf, yeah? You feel really good, very comfortable. What happens? Your heart rate is a bit slower, you feel peaceful. Hey, buddy.
Yeah,
Right?
but sometimes it's hard taking shit.
Okay. Yes, sometimes. Yeah, whatever. Yes, of course. We're just talking about taking shits here, you know? It escalated already. Minute one.
Hey, that's important for breathing.
It's important for breathing. No, so the point is that when your nervous system has a reaction, so for example, when you get scared, your breath naturally gets affected as well. Okay? And what we're going to focus on with breath work is the reverse principle of this. So we're going to use our breath to affect the nervous system because it works in both directions. If you, for example, breathe very shallow and very fast all the time, your nervous system has a reaction to that, or your nervous system will react or be affected by that. And the same way, if you have a certain way of breathing, you can affect the nervous system to be more calm. Okay? We're going to talk about the different nervous systems that we have, or the different types of autonomous nervous system and parasympathetic and sympathetic nervous system. We're going to probably talk in the next call. But for now, I just wanted to be clear that your breath affects the nervous system as much as the nervous system affects the breath. Even more, in my opinion. Okay? And just something to think about is that the animal with the lowest breaths per minute, so for example, whales, turtles, most of the um, animals that breathe like we do, what do we call them?
Mammals.
The mammals, most of the mammals that spend a lot of time underwater live very, very, very long. So there is a pretty clear correlation between the amount of breathing we do and the lifespan that we have. It's just something interesting, okay? So very basic biology here. Cellular respiration combines glucose and oxygen to create energy. Carbon dioxide and water are produced as a byproduct of the chemical reactions. Okay? You don't have to memorize any of this. It doesn't matter. It's just nice to have it there for those who want to be nerdy about this. Okay? That's just biology. The really relevant part, whoop, let me just try to hide you guys, sorry. Okay? Yeah. Good. You guys can see this, right? If you cannot, then just say something because I cannot see you anymore. So I just wrote down a couple of important things. The first thing is that I want you to understand the pH levels of the blood. Okay, so the acidity level of the blood, in other words. Breathing plays a considerable role in regulating the pH levels of our blood. The normal blood acidity, blood pH is 7.4. It varies from 7.35 to 7.45. And as you breathe faster, the pH level rises, and we become more alkaline. Okay, so alkaline means higher number. Yeah. As we slow the breath down, pH level drops and we become more acidic. Our body continuously monitors and regulates our blood pH by varying the rate and wow, I don't even know what I wrote there. If we're at rest, our breath is slow and shallow, but if we go for a run, we breathe faster and deeper, right? We want more oxygen in us. That's the sensation we have. The more rapid breathing reflects the body's increase in both energy and use production of carbon dioxide, which lowers blood pH, making it more acidic. So to regulate that, we need to exhale all that carbon dioxide out of our system. Okay? You can read this yourselves. I'm just going to try to read something out of a little book. Make sure I didn't miss anything important. No, it's good. Okay? You can read this yourselves. It's interesting. It's just to understand that when you're breathing, there's a lot of complicated stuff happening, okay? And one of those complicated things is that basically we're constantly regulating our acidity levels. And based on how we affect the acidity, there are certain chemical processes that happen. Yeah. You have a buffer system, so the carbonic bicarbonate buffer system maintains the pH level of the blood. If the blood is too acidic with too many free hydrogen ions, then the hydrogen ions combine with bicarbonate to create carbonic acid, which is then broken down into water and carbon dioxide to be expelled via the lungs. If the blood is too alkaline, water and carbon dioxide combine to create carbonic acid, and the process is reversed. Okay, again, this is one of those things that doesn't really matter. It's just nice to have it here for the super nerds here. And now we get to the really important stuff. A common myth is that if we breathe more, we get more oxygen. Normal blood oxygen saturation for a healthy person is between 95 and 99%. That's, when you're in the hospital and you're getting this thing on you that measures how much oxygen is in your blood. That's that. So a normal person has somewhere above 95%. The circulatory system acts like a series of subway lines. So you want to imagine that whole system that we have, the oxygen carrying system, is like subways. Yeah, the red blood cells are basically subways. And our oxygen carrying red blood cells, they deliver oxygen to the body. If the cars are full, trying to cram in more people is not going to help. Instead, we need to increase the number of cars, so more red blood cells, and their efficiency of getting people on and off the train. So how efficient are we at getting oxygen on and off the red blood cell and into our cells? Okay? So before I continue, you can tell me now if this is way too dry or if you're surviving. Surviving? So now it's going to get easier. I just wanted to do a little fancy intro. There's something that's really interesting. It's the Bohr effect. So basically, the Bohr effect has something that's a Nobel Prize winning physiologist, Christian Bohr, I think. Here it says Christian Bohr, exactly. So what he found out is that if carbon dioxide levels are low and blood pH is therefore high, then the red blood cells cannot release oxygen to the cells. So this is going to be explained now. Yeah. We're stimulated to breathe based on how much carbon dioxide is in our blood. Like there's some exceptions, people that have chronic respiratory illnesses, sure. But we hold our breath. As we hold our breath, chemoreceptors sense the decrease in pH, so we become more acidic. And then the increase in carbon dioxide means we get stimulated to take the next breath. Okay, so basically the sensation is we have a carbon dioxide buildup in our lung, and that stimulates us to take the next breath. More CO2, more urge to breathe. It's important to understand that that's not equal with the SpO2. So like the amount, like let's say again, when we're measuring the blood oxygen levels, the urge to breathe is not because you're missing oxygen in your blood. It's because you have a buildup of carbon dioxide, for example. Yeah? It's really important to understand that when you feel like you have to breathe, it has nothing to do with the level of oxygen in your blood. It has to do with the fact that you have carbon dioxide that wants to get out of the lung. For red blood cells to release oxygen, oxyhemoglobin needs carbon dioxide to increase blood acidity to facilitate the cellular exchange. That's called the Bohr effect. So what that means, to explain now, is that hemoglobin's oxygen binding affinity is inversely related both to acidity and to the concentration of carbon dioxide. So that means hemoglobin is an iron-rich oxygen-carrying protein inside red blood cells. There are about 270 million hemoglobin molecules per each red blood cell, and each hemoglobin molecule can carry 4 oxygen molecules. It's a lot of hemoglobin in one red blood cell. As carbon dioxide level rise, blood pH becomes more acidic. The bond between oxygen and hemoglobin is loosened. Oxygen can be released to the cell. So again, if there is carbon dioxide levels low and blood pH is high, then the red blood cells cannot release oxygen to the cell. What that means is that if you have too much oxygen in your body and not enough carbon dioxide is present, there cannot be an exchange. Your cells cannot actually take in the oxygen. That's something that really needs to be clear. So that's basically the Bohr effect. If too much oxygen is present, you're going to feel like you're choking. You feel like you're dying because you can't actually process and accept the oxygen into your body. You need carbon dioxide present for the exchange to happen. Okay? This is super, super relevant to understand. Which is, by the way, why when people hyperventilate and they have a panic attack and they're feeling like they're dying, they cannot take a breath, what do you do with them? You give them a bag to breathe in, right? Because what you want is you want them to have more carbon dioxide present in the body so that there can be an exchange of oxygen into the cells. Otherwise, you're going to feel like you can't breathe because you have too
You
much
get to
oxygen.
slow down the breathing itself.
It's not slowing down the breathing. It's about having more carbon dioxide present so that you can actually take in the oxygen into your body. Basically, that's the idea of the Bohr effect, okay? So oxygen has a strong affinity and attraction to hemoglobin. All right, doesn't matter. We don't need to go into the fancy shit now. Let's not get lost with it. The body's ultimate use or lose system. So whatever we do, our body works to support us. If you run all the time, your body will help you get better at running. You're going to grow more muscles. You're going to get stronger in your tendons. You're probably going to get a better endurance, right? Like your body wants to support you in the things that you do. If you sit on the couch all day long, then your body gets really, really good at sitting on the couch. So since the body's main concern is survival, and survival is dependent on having energy to fuel your body and have the reserves to fuel the body in case the fuel runs low, what that means is the body is very lazy if it can be, right? So muscles take a lot of energy, for instance, right? We have an aerobic system and an anaerobic system. If you are running chill, you're using mostly oxygen for energy. So since muscle takes a lot of energy, that's why we atrophy in the muscle shrinks if you don't lose it, if you stop using them. Because it's like, why have muscle that uses energy if you don't use it? And fat is our, let's say, is the body's way to store energy, which is why it stores any excess it receives as like adipose tissue. So it's kind of, that's where our energy gets stored, not in muscle. Every second, approximately 2 to 2.5 million of our red blood cells die, and the same amount, so 2 to 2.5 million red blood cells get created in the bone marrow. The lifespan of a red blood cell is around 3 to 4 months before it gets replaced. But that's based on the body's demand. So the body responds to what we've been doing, not what you want to do with it in the future, right? So if you don't give the body a reason to produce more red blood cells, when the red blood cells die or get decomposed after 3-4 months, it's not going to produce more because it's like, why would I produce more? He's not using them. Okay, so as an example, if you breathe too much, you have like something called chronic overbreathing, carbon dioxide levels stay really low. Red blood cells can't release oxygen because there's no carbon dioxide present, so you can't release the oxygen, as we said. That's the Bohr effect. And the body thinks that it has too many red blood cells, so the old ones don't get replaced when they die. So we're basically left with the bare minimum red blood cells possible to survive. Okay? If we run at that stage, we're going to be out of breath really quick. You're also not going to be able to hold your breath because the blood oxygen level is going to drop really fast. There's no extra blood cells circulating in the bloodstream. Okay? Carbon dioxide stimulates us to breathe. As I said, if there is carbon dioxide in the lung, that's going to be the stimulus of I want to breathe. And it allows oxygen to be released from the red blood cells so it can be used by the muscles, organs, and every other cell in our body. Yeah. It also opens airways. It means it helps us breathe better to have carbon dioxide present. It expands blood vessels, so lower blood pressure, and it allows blood to perfuse extremities with less effort by the heart. The opposite happens when carbon dioxide levels are low. The airways get smaller and the blood vessels constrict. Carbon dioxide levels decrease means blood vessels going to the brain constrict. The brain receives less blood flow and oxygen, is why we get lightheaded and dizzy from hyperventilation. Which is, again, so now the fancy term, what Ali said earlier, if I don't have enough carbon dioxide present, my blood vessels going to the brain constrict, the same thing that happens when you smoke. The brain receives less blood flow and oxygen, and that's why you feel dizzy, which is why we want to breathe into a bag when we hyperventilate to create more carbon dioxide, which allows us, again, for a healthier, higher blood pressure, and so on and so forth. Nose breathing, and this is going to be very important now for, like, now we start talking about the material of breathwork. Nose breathing means 50% more airflow constriction than the mouth, and it provides nitric oxide. So a mouth breather breathes twice as much as one should be breathing. Mouth breathing leads to lower levels of carbon dioxide, means red blood cells can't release oxygen. If they can't release oxygen, then cells are not adequately perfused, which means the red blood cells return to the lung full of oxygen. And then the body's going to take that as a waste of energy, because why would you have red blood cells full of oxygen? So the red blood cells don't get replaced. Okay, so that's kind of the full cycle on the carbon dioxide. Then a quick thing on nitric oxide. It's a signaling molecule made in the lining of the blood vessels in the nasal cavity and the paranasal sinuses. So like that area that we have around the nose and behind our cheekbones and above the mouth, okay? If you inhale through the nose, nitric oxide is carried into our lungs and through the rest of the body. If you breathe through the mouth, that doesn't happen. Nitric oxide works alongside carbon dioxide to assist with oxygen binding and release, and increases cellular oxygen uptake by 10 to 20%. Okay, the rest you can read yourselves if you're interested. I will just talk now. I think it's really important to understand this. If you are always breathing through your mouth, which most people truly are, like on a daily basis, they're breathing very shallow and they're used to usually breathing through their mouth. They're missing quite a few very important aspects. So first of all, they're not using much of their sinuses, because the sinuses is mostly accessed by the nose breathing, and they are going to lack the nitric oxide in their breath and then in their body. Okay, as you can see here, it has a lot of benefits to have nitric oxide in your body. People with low yeah.
What about the diagram breathing from the stomach? Like when we go to do presentation in front of a lot of people, you start panicking, even like scared from people, and then the technique that you breathe from your diagram from here and to keep it, so it will really relax you, and you can pitch front hundred of people without panicking, like the diagram of your stomach.
Okay,
You breathe from inside.
Wait. Yes, no, easy. Let's first talk science, then we're going to talk about breathwork, and then In 2 or 3 calls, we're going to talk about different ways that you can use the breath to affect the nervous system, but we're not there yet. Now it's just first understanding the different, let's say, parts of breathing, the different parts of the actual air going into your body, okay? Actual air going into your body, meaning we've talked about the Bohr effect, the importance of carbon dioxide, how it affects your acidity levels. The last thing is the nitric oxide. So people with low levels of nitric oxides are more likely to have cardiac problems, high blood pressure and heart attacks, and increased risk of strokes. As we get older, the nitric oxide production naturally decreases. So it's important that you work to increase that. So for example, to have a steady practice of breathing through your nose. It should become natural throughout the days. And then lastly, this is going to be important for us now when we talk about actually doing the breath work. The posture is very important, because if you have shitty posture, and that's, for example, also Ali, what you're going to talk about diaphragmatic breathing. If you have a shitty posture, meaning you're slouching forward, your shoulders are rolled forwards, the chest compresses, the sternum and the rib cage have trouble expanding. So the muscle that you need to basically inhale and open up your lung gets kind of pinched together. It gets squished. The diaphragm isn't able to contract properly and pull down to expand our chest as we inhale. So poor posture leads to compensatory breathing patterns like lifting the shoulders, lifting the collarbones, and that can actually lead to chronic back pain, which most people have because they breathe like shit. Yeah. With regard to the nervous system, a lot of this bad breathing, so chest breathing, because you can't access your diaphragm, it also creates a lot of negative stimulus on the nervous systems, which we're going to talk about later. Okay, so just something to understand. This is, you can just have a look at it. I don't want to bore you with it. You have a couple components of the lung, different, the different layers. So where the air goes in, and then it gets perfused, and then eventually it arrives in the tissue. You see it really nicely on the bottom, CO2, O2 exchange. Okay. On the right side, you see the muscles necessary for breathing. So it's a lot of muscles actually necessary. It starts all the way basically in scalenes in the neck, which you shouldn't use too much, but they're going to be necessary because they affect a lot of things in how the upper respiratory system works. And then you, of course, have the obvious stuff, the ribs, intercostalis muscles, and so on. And the most obvious one is your diaphragm. The diaphragm kind of contracting and pulling down. So what you can imagine, the picture on the left is nice. You have a small jar with a balloon in it. If the jar would open, the balloon could expand. And so that's what you want to think about your lung. If your muscle expands or allows the rib cage to open, the lung just basically expands with it. It's glued to your chest cavity. So if your chest opens, the lung opens, and then it inhales. It sucks in air. Okay? We don't need to look at that. Something for you guys you can look at if you want. It's just, it's a nice way of putting the overbreathing or underbreathing. Okay, so the positive effects of it. I can share all of this with you. I can share the presentation with you when we're done so you can read through it properly. I don't want to get stuck on the details now. Just something that's important now before we do the actual breath work for today is to understand what the nervous system is. Okay? When we talk about the nervous system, and I call this the autonomic nervous system and the polyvagal theory. Okay? So first of all, understand that there are kind of two nervous systems we're going to talk about. There's the central nervous system that's including the brain and the spinal cord. And there's the peripheral nervous system that comprises of the nerves that leave or return to the brain or to the spinal cord. Yeah. When we talk about the nervous system, we have the general, like the nervous system, as you can see, and then you have the central nervous system, the peripheral nervous system. And as part of the peripheral nervous system, we have what we're going to focus on most in these calls is the autonomic nervous system. And in the autonomic nervous system, we basically have the sympathetic and the parasympathetic nervous system. That's what you see on the bottom right of the screen. Okay? I will not dive into this because it's going to be way too much information. So I just wanted to be clear, or maybe I'm just going to read this to you because maybe that's going to be relevant for today's lesson. Bam, here. This is the two things that are just kind of relevant. Yeah, you have the sympathetic nervous system. It's known as the fight or flight response. meaning it is more active in response to stressful situations. And you have the parasympathetic nervous system, also known as rest and digest, that is more engaged when we are in relaxed states, such as, for example, when Yusuf is taking a shit. So it's vital for sexual organ function too. So most people, let's say, that have problems with sexual functions, they're usually just way too stressed. They are in a heavy sympathetic tone, as we call it. So yeah, it's important to understand that the nervous systems, they work in contrast with one another. So it's not that you are either in a full sympathetic tone or in a full parasympathetic tone. It's not like you're running all the time away from danger, right? You're not always in a super stressful situation. And you're obviously not always resting and digesting and sleeping. So we're always in a balance between those two. So you want to have some parts of the sympathetic nervous system. You want to have some sense of arousal when you are going through everyday life, when you're awake. But you also don't want to be overstimulated in it. So you want to have sufficient parasympathetic tone so you're not freaking out and having panic attacks all the time, right? So we're basically learning to have a balance between those two. So in our life, we're 99% overstimulated. We're almost always in a sympathetic tone. We're almost always in a fight or flight response, to be real. We're all the time stressed from work, stressed because you're not doing your fucking back layout correctly, and so on and so forth. Okay? So what I'm gonna show you today is my way of doing, let's say, breath work, my daily routine that I do that consists of 3 very simple breathing patterns. Okay, it's gonna take you roughly 10 minutes if you follow along. We're gonna do it every day that we do this call. We're gonna do it together until you remember it by yourself. Okay. Firstly, it's I will show it to you by hand. Okay. It's basically an inhalation of 3 seconds followed by a 2-second breath hold. An inhalation of 2 seconds followed by 3-second breath hold, and an inhalation of 1 second followed by 4-second breath hold, and the same thing on the reverse. So what that means is you can take your hand, you can touch 3 fingers together. That's your inhalation, 3 seconds. 3-second inhalation, 2-second breath hold. Then 2 seconds, 2 fingers together, 2-second inhalation, 3-second breath hold. And then 1 second inhalation, 4-second breath hold. And now you're going to reverse it. So now you have 1 second exhale, 4-second breath hold, 2-second exhale, 3-second breath hold, 3-second breath exhale, 2-second breath hold. Okay, so let's do that real quick together. It's quite easy actually. So you're going to go 3 seconds inhale slowly into the stomach. 2-second hold. Then you're going to do a 2-second inhale. 1, 2. 3-second hold. 1, 2, 3. And then a 1-second inhale and a 4-second hold. 2, 3, 4. 1 second exhale. 4-second hold. 2-second exhale. 3-second hold. And then all the way out, 3 seconds, full exhale, empty the lungs, empty the stomach, 2-second hold on the bottom. And we start again. Okay, so stop. That's pretty easy to understand, right? 3 in, 2 hold, 2 in, 3 hold, 1 in, 4 hold. Same thing on the way out. Okay? So for these breath works, it's important that you can differentiate whether you're breathing into your stomach, into your chest, or into your upper chest. So I will take my t-shirt off real quick because I want you to see that. If you're struggling with this, we're going to work on it separately. So you can breathe. If you look at my 2 hands, I want you guys to do that as well. So sit up in a good posture. Sit up straight. Nice posture. Okay. Place 1 hand on your stomach and 1 hand on your chest. Higher, Ali. Good. And now I want you to actually try to not move your chest when you breathe and only breathe into your lower hand. And don't force it. It should not feel like your stomach is doing this. It's really your breathing in a way that the bottom hand is moving. But I can see your top hand moving right now, Ali. Don't move the top hand. Okay? Something that is coordination. It's something to work on. It's easy when you lay down. And if you're struggling with it, a really nice tip is to activate your core muscle. So you try to just kind of activate the core, like contract your abs, and then try to breathe to your abs. Okay? Chris, sit up a little bit more straight. Good. And then try to feel that. Is it kind of working for you guys? That you're only moving the bottom hand? Yeah? Good. Now, the second exercise is you don't move the bottom hand. You're going to move only the top hand. So can you isolate those two? Let me just put on a t-shirt. Okay? And
To only move my chest, I feel like I need to press, like, how to say it, like, to use my muscles in my stomach to not move my stomach.
yeah, you can move your stomach inwards if you want.
Okay. Yeah, that's what's happening.
Sure, but so it took me quite a while to learn how to do this. As I said, for me, it's easiest when I'm laying down with my knees bent, and then I just put like this, and I try to feel the difference between those two breathing patterns. Yeah. And when we're gonna do breath work, it's very important that you learn to access your diaphragm, because most people don't know how to do that. So most people actually only use the chest when they breathe, but they're not using this. Like you see on me, if you're looking at the breathing, like there's a lot of breath going in here. And so this is something that we can also talk about in another call and really just talk about how to do that and do exercises for it. So today, what I'm going to ask you is that when you're doing the 3-second inhale, the first one, that it goes to the stomach. Then you're doing 2 seconds to the chest. And then you're doing 1 second to the upper chest. Same thing on the way out. 1 second goes out here. 2 seconds goes out here. And the third second, the third breath goes. Does that make sense? Good. Now, the next thing that we're going to do is a breath hold. And this is quite easy. We're going to inhale for 6 seconds. You're going to hold times 4. So 24 seconds. 6, 12, 18, 24. So you inhale for 6 seconds. You hold for 24 seconds. You exhale for 12 seconds. And you hold for 6 seconds. Let's do that together. So inhale for 6 seconds. You start with the stomach, 3 seconds into the stomach. 1, 2, well, sorry, let's start. Sorry. Take a deep breath first. Full exhale. Good. 6-second inhale. 1, 2, 3, 4, 5, 6. All the way. Hold it for 24 seconds. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Exhale for 12 seconds. So take your time on the exhale. 9, 8, 7, 6, 5, 4, 3, 2, 1. All the way out, and hold for 6. 2, 3, 4, 5, 6. Okay, so release it again. Does that make sense? Super easy, right? So you could do it with 5 seconds. Then you would hold it for 20 seconds, exhale for 10 seconds, hold for 5. It's always times 4, times 2, and that's it. Does that make sense? Okay, cool. So let's do a breath work together, yeah? We're gonna do 6 rounds of the first, 6 rounds of the second, and then we're just gonna do something really easy afterwards. Cool? You go fly?
Yeah.
Okay, cool. So, as I said, when you're doing breath work, it's important that you have a proper posture. You can do it laying down, but then make sure you're not slouching with your head forwards or your chest is collapsed. You got to make sure that you're in an open position. And when you're sitting like Chris, make sure you're sitting nice and upright. Okay? So I'll guide you guys through this. We're going to do the first one. So take a deep breath in, all the way out. Good. Inhale for 3, slowly in the stomach. 2, 3, hold for 2. Inhale for 2, hold for 3. Inhale for 1, hold for 4. Exhale for 1, hold for 4. Exhale 2, hold for 3. Exhale 3, hold for 2. Inhale for 3, 1, 2, 3, hold for 2. Inhale for 2, hold it for 3. Last inhale, 1 second, hold for 4 seconds. 2, 3, 4. Exhale 1 second, hold 4 seconds. 2, 3, 4. Exhale for 2, hold for 3. Exhale all the way 3 seconds and hold for 2 seconds. And again, 3-second inhale, hold for 2. 2-second inhale, hold for 3. 1-second inhale, hold for 4. Exhale 1 second. Exhale 2 seconds. Exhale 3. Hold 2 seconds. Inhale again 3 seconds, slowly in the stomach. Hold 2 seconds. Inhale 2 seconds, chest. Hold it for 3. Inhale one last one, 1 second. Hold it for 4 seconds. And again, exhale 1 second, hold it for 4. Exhale for 2, hold it for 3. And exhale all the way, 3 seconds. Beautiful, hold it for 2. Remember, you can do this thing with your hand. Inhale for 3. Hold it for 2. Inhale 2. Hold it 3. And last one, inhale 1 second all the way. Hold it for 4 seconds. 2, 3, 4. Exhale 1. 1, 2, 3, 4. Exhale 2. 1, 2, 3. All the way, 3 seconds. Hold it for 2. One more time. 3 seconds. 1, 2. 2 seconds. 1, 2, 3. And last one. 2, 3, 4. Exhale for 1. Exhale for 2. Exhale for 3. Hold for 2. Last one. Hold for 4. And exhale for 1. Exhale 2. 3-second hold. And all the way out, 3 seconds. All right, take a breath. Very nice. Okay, this for me is something I like to do. It really calms me down. It feels longer now than when you're going to do it by yourself. Now that you have the hand system, it feels good, yeah? Second thing we're gonna do, as I said, is the breath hold. So take a deep breath in, all the way out. Inhale for 6 seconds. 3 to the stomach, 3 to the chest. 4, 5, 6, and hold it for 24 seconds. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Exhale 12 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold it for 6 seconds. 2, 3, 4, 5, 6. Inhale 6 seconds. Stomach first, slowly. And then the chest. 2, 3. Hold it 24 seconds. I will not count. 10. 20, 21, 22, 23, 24. Exhale for 12 seconds. All the way and hold it for 6. Inhale for 6 again. Hold it for 24. 1, 2, 3. 20, 21, 22, 23, 24. Exhale for 12. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All the way out. Hold it for 6. 2, 3, 4, 5, 6. Inhale for 6. 2, 6. And hold it for 24. You got it. Let's do 3 more rounds of this. You're gonna benefit. You're gonna really like it after, I promise. Twenty, 21, 22, 23, 24. Exhale for 12. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All the way out. Hold it for 6. Inhale 6. Stomach first, slowly. Chest 5, 6. All the way. Hold it for 24. 2 more rounds. 10, 21, 22, 23, 24. Exhale for 12. Slowly. Chest first if you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All the way out. Hold it for 6. Last one. And inhale again. 6 seconds. Slowly. Stomach first. Hold it 24, 23, 22. 3, 2, 1. 12-second exhale. Slowly. Take your time. If you see colors, that's good. If you feel relaxed, that's good. If your heart is beating, that's good too. all the way out, all the way out, and hold it 6 seconds on the bottom. Good. Take one big breath in and exhale again right away. All the way out, all the way to the bottom, all the way to the bottom. Now 15-second inhale, very slowly. Take your time. Inhale slowly. 2, 3, 4, 5, 6, 7, 8, 9, 10. Take your time. 13, 14, all the way in. 15, 20-second exhale. Super slow exhale. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. You still have 10 seconds to exhale. 7, 6, 5, 4, 3, and all the way out to 1. Empty. 15-second inhale again. Super slow. Start slowly. Stomach first. 5, 6, 7, 8. Feel how it's slowly going up into the chest. 11, 12, 13. There's still some space. More, deeper. 20-second exhale. Take your time. Slowly. 18, 17, 12, 11, 10, 9, 8, 7. You see, like really take your time. 5, 4, 3, and all the way out. 2, 1, 0. And last one, 15-second inhale. And then when you're finished with the 15, you're counting yourselves. You exhale for 20. Good. And when you're done, I want you guys to actually just chill for 2 minutes. You can close your eyes. You don't worry about the breath anymore. Close your eyes in whatever position you're in. Give yourself a nice posture. Enjoy the fact that probably now you feel a little bit more chill and actually feel how it's relaxing. Okay? This is a really nice way to start meditating. It's a very good way to, as I said, for me, I start my day like this and I finish my day like this. I will write you guys this whole thing again and we're going to do it every week together. Okay? So I'm going to hang up and you guys can just enjoy whatever state you're in. One love, my friends. Good night.